Okay, welcome back. HVAC 202 lab final short videos. This one's over at Contactor. We're gonna check the contactor to make sure it's doesn't need to be replaced, and we are going to check it unpowered and powered. So it's unpowered right now. How do I know? I've got my set the volts. I come here to my low voltage stuff and I get on there and I have nothing. I come in where my whip is coming up to the high voltage. I get on there and I got power. So guess what? I'm going to pull the disconnect. Oops. Close the door for safety. Got it on top. All right. So back to this again. Whoops. I accidentally pulled it all the way off. All right. I'm on the metal. I have nothing coming over here. No call from the indoor air handler. Okay. I want to check the bottom where the wires come in for high voltage to run the motors. I got nothing. Okay. Just to be extra cautious, I'm going to take one leg and I'm going to go right to the ground screw. I got nothing. I'm going to stay on the ground screw. I'm going to go to the other side. I got nothing. Okay. I'm going to go to the top. I should have nothing, and I got nothing. And to make double sure, I'll just go back to the ground screw on each side. And I got nothing. Okay. So 6 ways to Sunday. 1, 2, 3, 4, 5, 6. That's 6 ways to Sunday. Okay. Now, I'm going to power up the unit. There's 2 different powers. The low voltage control power that comes from the indoor air handler unit, and the high voltage power to run the motors that comes from this disconnect. So I'm going to turn on the low voltage first. And that I should now have power going to the transformer that powers this. I'll just slap it to cool. Okay, you heard the click, click. That means that the low voltage coil, that click you heard was the low voltage coil pulling the switch in. But I'll go here and check and make sure. I should still be on volts. I'm on volts. So I have a call, a low voltage call to go, all right? I have no high voltage power yet. So I'll go up here to the disconnect, put her back in. Correct? Not correct. Unless it's upside down on yours. Good enough? You heard it light up? We're running. All right. So there's an additional test that you want to do. You can do the safety test. Are the motors getting what they need? Okay, well these are 208, 230, 240 motors. They'll run on any of them. So yes, I'm getting what it needs. Is this switch, is this contactor putting the voltage out to the motors? Yep, looks like it is. Okay, everything's cool. Here's the important part. This is a straight leg. There's a metal bar in here that I'm touching right now that goes from this lug to that lug. The input power to the output power of the motors. So it ought to be 0 volts lost or dropped or consumed when I measure across this leg, this straight leg, because there's no switch there, and that's what we got. So it's letting all the power that comes in go to this screw out to the motors. Now the switched leg, this is the leg that has the switch in this case. If I measure across the switched leg, I have 0. And that means it has let all the power that's coming into here is getting out. If I had a power loss or drop of 3 volts or more, it's an automatic replace the contactor. Good? Good. I want to show you one more thing. Okay, this is really for a disconnect. You don't need to do this on this, but I can prove it. Now, I'm trying to tell you how to be more safe with these contactors. Okay? It's the crisscross applesauce. Okay? I've left the high voltage going to the motors on, but I turned off the cooling coil. So, yes, I still have voltage here, I guess. No, I don't. And I don't have voltage, and why is that? Because I do not have a call from the thermostat. So it is not taking the R inside the thermostat and connecting it to Y to bring it out here. That's why I have nothing, okay? So I don't have a call for the machine to run. Great. But I still have high voltage on here. And here's what I want you to be careful with, is this right here. You know, if I test this, yes, I have the 240 and I can do that to ground. I can do this side to ground. But this says up on the top, I have nothing, right? Nothing. I have 240 coming in, but I don't have it going out. So I should be safe to touch any of this stuff here, disconnect this stuff, disconnect it from the capacitor, take off the lid, pull the motor out, but it's not. So if I do crisscross applesauce and I go from the bottom of one side to the top of the opposite side, in this case I got a 0. And if I go from the bottom of the opposite leg to the top of the opposite leg, so you got 215 volts. Okay, so it's a safety check. Crisscross applesauce is a safety check. And you can do it in this one doesn't have it. It's a pull disconnect. But if I had fuses in there, I could do the crisscross applesauce, besides just checking it coming in, whether it's coming in top or bottom, and the out, do the crisscross applesauce. One, that'll tell me if the fuse is good or bad. Because a fuse is just like the straight leg. It should let everything through. If I had a good fuse here and a good fuse here, this would work both ways. If I don't have one of the fuses good, it won't work one way and it will work the other way. And that's how you can identify which fuse is blown. That's extra tidbit for you. So to summarize the contactor deal, I can check it hot with voltage, make sure the low voltage is getting what it needs, make sure the high voltage is getting what it needs, right? And I want to make sure that it's utilizing all the high voltage that it's getting for the motors. That's the hot check or the live check, okay? The unalive check only has one more aspect to it, so I need to unalive it. I could go over there and turn off the inside. And for you more advanced people, I can come here. Now, I don't have a call because that's not pulled in. But this is the common. If I chase it up, it's going to say common up here. So this is the common. If I pull the common and I still have electricity coming from the air handler, if I accidentally touch this on something, as long as the stuff is grounded, you know, the transformer's grounded, I don't have a problem. If I pull one of these hot wires or signal wires and it accidentally touches something, I'm in big trouble, okay? I just blew a fuse over there, at least a fuse, maybe the thermostat, maybe the fuse, the thermostat, and the transformer. We don't know. It could be all kinds of stuff. A circuit board over there, circuit board over here. So this is the last thing. I'm going to check the low voltage coil with ohms. So I'm on the metal on this one. I've disconnected one side to make sure the meter is only reading through the coil. And I got, looks like 14.15 or something like that from here. I can barely see the meter, okay? So, unpowered, besides the safety part of the unpowered, I want to check the ohms across the winding, which is the coil, the contactor coil, to see if it's intact and can do work. If it's OL, the coil is bad. If it's really close to 0, 1 or 2 or something, then it's bad. And I don't even need to do the live check. Okay? But, you know, I could do the live check, but why do it? I already know it's bad. It needs to be replaced. The live check, the most important thing there is it getting what it needs? And is it letting all the voltage across the switches? And this is not a switch, it should, but if that metal bar was to come a little bit loose or start melting or something, it would do the same thing. It would lose voltage across the metal bar. Good? That's it. Thank you.